I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back another session of Artificial Intelligence. So in today's class, we will discuss what is logic programming, and we will see how it will came familiar, and what is how we will write the programming using the logic programming. Let's see the overview of logic programming. In today's session, we will see the what is the logic programming introduction and how we will write the programming, and simple two examples we will see. The introduction part is in logic, when it is started and who is proposed. The logic program was first introduced by Clausal in 1974. So in the year 1974, the Clausal is introduced first. The logic programming was. Okay, it is based on first order logic. So basically it is already there, the first order logic, it will be derived, and after that it is came the logic programming. A programming usually a collection of program clauses. In first order logic we'll have some derivations and simple formulas. Based upon that we have taken logic programming. In this logic programming it is a collection of program clauses. Okay. A clause of FOL is represented in clausal notation in logical programming. So this clausal notation is written in the form of positive literals implied by the negative literals. Let's see, where P is represented as a positive literals and N is represented as the negative literals, and this symbol is called as the implied by symbol. Okay. Next, the conversion of a clause into clausal notation. So here a clause in FOL denotes a closed formula, and it will be literals L1 disjunction, L2 disjunction, and so on LM, where each LK is a literal which is free from quantifiers. We know already what are the quantifiers. So there are two quantifiers. One is for all, another one is there exist, and all the variables occurring in this formula are in this form is universally quantified. Now the positive and negative literals are separated by this formula. Let's see. So this is the closed form, L1 disjunction, L2 disjunction, and so on LM equal to first positive literals P1 or P2 or P3 and so on PK, or negation of N1 or N2 or N3 or and so on, negation of NT. So the same we can rewrite as, by taking negation is outside, we can write like this: positive literals first using the disjunction symbol, and after that taking the negation symbol out, writing the conjunction symbol inside the negative literals. So the same here we can write negative literals implied by positive literals. So here we can write positive literals like this, otherwise negative literals and positive literals. P implies Q. This is the one of the rule we already know. P implies Q equivalent to negation P R Q. So here it is also the symbol of R in the negation form, but we are taking the negation is outside, so we are writing and symbol inside the negative literals. So the clausal notation is written in the following form, either in this way or in this way. The implied by symbol direction towards the positive literals, and here this disjunction is used by using this comma, and here the conjunction is used by using the comma respectively, first in the positive literals and second in the negative literals. When we see the positive literals separated with the comma, then we should write the disjunction. When we see the negative literals separated with the comma, then we have to write with the conjunction respectively. Okay, so let's see the same. It must be noted that the interpretation of P implied N is the same as N implied P. The symbol is read by the implied by. The literals denoted by P are positive and N is the negative. And in clausal notation, all variables are assumed to be universally quantified. And negative literals are called as antecedents, and positive literals are called as consequence. Antecedents and consequence. So the commas in antecedent and consequence denote conjunction and disjunction respectively. Okay, next, To understand the concept of logic program, it is important to familiar with the following terms. So the first one, the basic constructs of logic program are inherited from FOL. Already we have discussed. There are three basic statements of logic programming, that is the rules, facts and queries. We need to write the program using these three terms, that is the rules, facts and queries. Let's discuss the terminologies. The first one, a logic program is a finite set of program clauses. It will be defined on the conditions. A logic program is a finite set of program clauses. Next, a program clause is a clause that contains at most one positive literal, one or none, and is represented with P is a positive literal implied by N1, N2 and so on, Nn. This N is the body of this clause. P is the positive and N is the negative. This P is the consequent and N is the antecedent. It is known as a conditional clause because interpretation that P is assumed to be proved if N1 to N are proved. If this body part is proved to be true, automatically P is true. Because P implied N, we can write PR negation N. So this is the rule. Okay, that's why when this body is true, automatically P also will be proved to be true. And this program clause is also called as rule. The positive literal P is called the head, while the collection of negative literals are called as the body of the program clause or rule. The truth then, here already we have discussed, the informal semantics of P implied by N1 to Nn is the for all interpretations of if N1 conjunction, N2 conjunction and so on, Nn is true, then P is also true. The formal interpretation of this rule states that P is proved if N1 to N are proved together. So in this statement, a program clause is also called as rule, and here it is represented as at most one positive literal and followed by N1 to Nn negative literals. If N1 to Nn negative literals are true, automatically P also will be true. P is called as head and N1 to Nn is called as the body of the program clause. Next, the second terminology, a clause that does not contain a body is called a unit class. So in this case, it contains only P implied. A clause that does not contain a body is called the unit class and is represented like this. This implies that P is always true for all interpretations. There is no negative interpretations, so P is always true. Alternatively, a unit class may be defined as a program class with an empty body or a clause with only one positive literal and no negative literals. A unit clause is unconditional and is therefore also called a fact. So this one is called a rule and this one is called as fact. So only one positive literal and the symbol is implied will be there. So this one is called as positive literals. The next one is queries. A clause that has empty consequent is known as a goal clause. It is in the form of implied N1 to Nn. That is, a goal clause has no positive literal. So each N is called a subgoal of the goal clause. Goals may be defined as a ground or non-ground. Let's say, if all the arguments of a goal are constant, then the clause is called the ground goal. If it is all are constants, then it is ground goal. Otherwise, it is called as non-ground goal. Next, a clause with the empty consequent and empty antecedent is known as empty clause. And this clause is to be regarded as a contradiction, conflict. And it is denoted by the symbol X, contradiction. Okay. All the results of FOL hold true for the logic program. Let's see here. A goal G with respect to a logic program PL, finite set of clauses, already we have seen, is solved by showing that the set of clauses programming logic union negation of goal is unsatisfiable, or that there is a resolution refutation of this programming logic is union with the negation of goal, then that is called as empty. If it is a contradiction, then we can say this G is a consequent or resolvent of this logic programming. We will see one example. If so, then G is said to be a logical consequence of a logic program PL. Let's see the example. So here, rules, facts and goals. So the rules are: X is a grandmother of Y if X is a mother of Z and Z is a mother or father of Y. There is no specification. So here we have written like this: grandmother of X comma Y is implied, mother of X comma Z comma parent of Z comma Y. Then how we will convert this as like this: grandmother of X comma Y, or negation of mother of X comma Z comma means, or negation of parent of Z comma Y. How we have written this one? Based upon the rule, if P implies Q, then P or negation Q. That is what we have applied here. In the similar way, this one also. And here these are the facts, and here these are the variables, and these are the values bounded with these variables. Based upon these facts and rules, the goals, whether it will be yes or no, we need to find out by using the logic programming. So in the prologue logic programming, we will write like this: all the rules and the facts. Let us check whether first we'll answer the questions. The first one, the goals: grandmother of Mary comma Mike. So here the description of goal is Mary is a grandmother of Mike or not. So we'll go like this. The first, John is a father of Mike. Okay, let's see where is the John. Okay, Mary is a mother of John. So here John is a father of Mike and Mary is a mother of John. Now link this one. Mary is a grandmother of Mike? Yes, true. Next, grandmother of Mary comma Mita. Let's check with the facts. It will backtrack one by one. Later it will decide whether it is true or false, or it will give some output. Okay, so first, Mike and John, no. Then it will go to Kittu and Mita. Yes, Mita. Kittu is the mother of Mita. So, Kittu is the mother of Mita. Next, Tina is the mother of Kittu. Tina is the mother of Kittu. There is no relation with Mita and Mary. So, is Mary is a grandmother of Mita? No, false. Next, grandmother of X comma Mita. Who is X? Who is grandmother of Mita? That is the question. Goal. Then again we'll go like this. Kittu is the mother of Mita and Tina is the mother of Kittu. So, X is a grandmother of Mita. Who is the X? Tina. Next again. Whose grandmother is a Tina? So, we need to find out who is X. So, here say Mita. The same question. Okay. Based upon the facts and rules, we will derive the answers. Next, we'll write in this way in the logic programming. After conversion implied with the disjunction symbol, we'll write like this. So by applying the rule, already I have said, P implies Q equivalent to P or negation Q. Next, check whether the ground goal implied grandmother of Mary Mike is true or not. So to do this one, we need to add negation of the goal of the set PL to get a new set S, where S is defined as programming logic union negation of G. Then we can say whether it is true or false. Let's see all the rules and facts, and at last the goal. Negation grandmother of Mary, Mike. Why we have added negation? Because here there is a rule to define whether it is a contradiction, then we can say it is the true. Let's see how. So here the resolution tree. First, we'll take the goal. What is the goal here? Negation grandmother, Mary and Mike. So we'll apply the similar one. So here L1 and L2 will combine these two classes and we'll get the new class. And again we'll apply another one. Again we'll get the new one. Until unless we'll finish all this tree, we'll need to go to the end. Okay. So negation grandmother and grandmother. So we'll take 1 and 8th rule, and here grandmother Mary, Mike from 8th rule, and first one grandmother of X, Y or negation mother of X, Z or negation parent of X, Z, Y. Now the Mary is bounded with X equal to Mary, Y equal to Mike, and Z is undefined. So here from 1 to 8, from grandmother to grandmother, we eliminated this one. Positive grandmother, negative grandmother. So what are the left one? Negation mother X, Z, negation parent of Z, Y. This is the new class after the first and 8th rules collapsed. So here X is already defined as the Mary and Y is already defined as the Mike. Z is undefined. Let's see here. So first and 8th rule, X is Mary, Y is Mike, and the new class is negation mother of Mary, Z or negation parent of Z, Mike. We need to search either positive mother of Mary or positive parent of Mike. Let's check. So here, if you see, the parent is bounded with the variables only. So we need to go with the Mary. So mother. So here, mother of Mary. So which one is having mother of Mary? This first one. So we'll take the 4th one as the next clause. The 4th one. The 4th one already having Mary, John. So the first one already Mary is there. The second Z is bounded with the John. Now this negation mother and positive mother from the 4th rule will be resolved, and the new class is negation of parent John, Mike. Now we need to search for the parent of John, Mike. So here if you take this 2 and 3, both are parent of X, Y or negation of father X, Y. Parent X, Y or negation mother X, Y. So we'll take the second one, and here the second one with this new class negation parent. So we'll have X, John, Y, Mike, and the new class is negation father of John, Mike. So we'll check for the father of John, Mike for the contradiction. So it is empty class. So we can say, since a contradiction is deduced, we can say that the goal is proved or true. What is the goal? Mary is a grandmother of Mike, because here we shown this as a contradiction with the negation. So we can say that this Mary is a grandmother of Mike is true. Let's see similar one. Check whether the non-ground goal grandmother of X is a grandmother of Meta is true. So X can be anything, that X is a grandmother of Meta. From the previous rules, change this grandmother. Negation of grandmother X, Meta. Add only that one and start the same resolution tree and we'll get the same thing. So that will be true. Okay, let's see the resolution methods. So the resolution is a powerful inference technique which takes two classes as input and it will give the new class as the output. The output class is called as a resolvent. If the resolvent obtained is a fact, then it is said to we have proved a fact. And if the resolvent consists of an empty class, then we are said to have proved that set consisting of resolved class as unsatisfiable. And there are three important cases of resolution used in reasoning, that is backward chaining, forward chaining, and rule collapsing. Let's see one by one. In backward chaining, it will start with the goal and it will match with the rule. Let's look at the definition. One of the classes resolved is a goal class. A rule is chosen such that its head matches with the goal class. The resolved class is a goal class consisting of sub-goals of the rule. That is, sub-goals are specified in the body of the rule. So it will take the goal and it will matches with this head. Next, in forward chaining resolution method, one of the clauses is always a fact. Here, rule having negative of the atom representing the fact is chosen. The resolved clause is generated by cancelling out negative atom with the positive atom fact from the body of the chosen rule. Next, in rule collapsing resolution method, two rules are identified in such a way that one rule has a positive atom head and the other rule has the same atom negative in its body. So that will be replaced with the negative atom is replaced with the positive atom. These two rules are joined by replacing negative atom in the rule by the body of the rule having the positive atom. Let's see the examples. So the first one, backward chaining. So goal class is resolved with one of the given classes. Let's see the first one, P implied by Q comma R. So the result is Q comma R because P R negation Q R negation R. Okay. Next, the P is only negation P. With this, we can resolve these two, P and negation P. The resultant is negation Q R negation R. That is backward chaining. We'll going from the back, means with the goal class, we are moving towards to match the head. Next, forward chaining. One of the clauses is always given fact in clausual form. So here P implied Q comma R comma S. So we can rewrite this as P R negation Q R negation R R negation S. Later R is the positive letter. So we'll write like this. So this R is resolved with the negation R. The resultant is P R negation Q R negation S. It is the same as P implied Q comma S. So this R and this R will be resolved. Next, rule collapsing. Consider following two program classes. The head of class 2 is present in the body of the class 1. So look at here, P implied Q comma R comma S. In the second class, R implied T comma U comma V. So this R will be replaced with this positive atom in rule collapsing. That is what here we have done. P implies Q comma T comma U comma V comma S. So the result is the same as this one. So in this resolution methods, three types are there: backward chaining, forward chaining, and rule collapsing. So in today's session, we have seen the logic programming, and what are the resolution methods and example. Thank you.